Hello, today we are going to talk about dividing polynomials. This is chapter 11, section 5 in our book. It starts on page 706 and goes through 711. We have 3 topics we have to cover in this section, and let's get started. So, to divide polynomials by monomials. Okay, so many terms, probably a quadratic or maybe a binomial, divided by a single term, a monomial. Our goal is to divide each term in the numerator by the denominator. So we're going to take one fraction and make many fractions, and then we're going to simplify each of those fractions if we can. Okay? So again, you're going to take notes. Not much here. Not much on the second one either, note slide. However, the third one is a little tricky. So let's get started. So here's what the problem's going to look like. We have 2x squared plus 6x divided by 2x. So all we're going to do first, the first thing you want to do is take this problem and put it into a fraction. Okay? Now remember, to divide these, you have to divide each term in the numerator by the denominator. So this is going to turn into 2 separate fractions. 2x squared divided by 2x plus, that sign is always that sign, 16x over 2x. And then we're going to reduce these. So we can divide 2 by 2, which is 1, and x squared divided by x is just x in the numerator. So there's 2 x's in the numerator, 1x in the denominator. One of them is going to cancel this one out, and we're left with just x in the numerator. And then 16 divided by 2 is 8. X divided by x is 1, so these cancel, and we're left with just x plus 8. Gone. 1 remains in the numerator. 16 divided by 2 is 8, and these are gone. So this ends up being just x plus 8. Okay? So once you guys give this a try, pause the video and give this a shot. See what you come up with. When you're finished, hit play and see if you got it right. All right. So I rewrite as a fraction. Okay? I'm then going to turn this into 3 different fractions. Okay? X squared divided by 3x, and then plus 12x divided by 3x, and then minus 14 divided by 3x, and I'm going to reduce. Okay? 1x here cancels this x out, so we're left with just x plus x over 3. Plus 12 divided by 3 is 4, and these x's cancel out, so this ends up being just 4 in the middle. And then the last term, minus 14 over 3x, does not reduce at all, so this isn't changing. And there's our answer. Okay, let's take a look at the next type of problem. The next type of problem is dividing a polynomial by a binomial, which we have done a ton of already. The last 3 sections have been about this. The last 2 sections have been about this, sorry. And so, just like we've been working on, we're going to factor the numerator and then cancel out like terms. Okay? So, and again, that factoring could be GCF, could be a quadratic. I mean, it could be a lot of different things. But the point is you got to factor it. So, here we go. Here's our first problem. Just watch this one. X squared plus 9x plus 18 divided by x plus 6. Same steps as the last problem. We're going to turn this into a fraction. Now, we can't divide these directly, so what we're going to do is factor the numerator. All right, and that becomes factors of 18 that add to give me 9 are 6 and 3. Signs are the same. They're both positive, so x plus 6, x plus 3. Notice these cancel out, and we're left with just x plus 3. Now, in a later problem, the third example in this set, if you were to do this and nothing canceled out, then you're going to have to, do the example 3, which we'll talk about in just a second. So, give this one a try. Pause the video. After you've finished, hit play to see if you got it right. All right, so here's my fraction. I'm going to factor the numerator. Factors of 15 that subtract to give me 2 are 5 and 3, with 5 being the negative because I need the result to be negative. So x minus 5, x plus 3. Quick check. Negative 5 times positive 3 is negative 15, and negative 5x plus 3x is negative 2x. These are going to cancel out, and all we're left with is x minus 5. So these first 2 examples, very similar to all of the things we've worked on. And really, it's just being able to take this into this form. It's about all this first part of the lesson is covering. Which brings us to the last example. Long division. That is the Wilhelm scream. Look it up. It's kind of interesting. So use long division. We're going to divide the first term of the dividend by the first term in the divisor. Okay? And remember that the dividend is what's inside our division, right? And the divisor is what's outside. So all you're really doing is looking at the first term of each. And this process just repeats. It's the long division algorithm. Okay? So really what you're asking yourself is, what do I have to multiply the first term of the divisor by to get the first term in the dividend? Okay? And that's going to be your essentially your quotient, your answer, at least part of it. All right, and then you're going to distribute or multiply that quotient by the divisor, and that's what you're going to be subtracting. Okay? You're going to repeat this process until there's just a constant remaining as the remainder. Once you've done that, you're going to write your quotient, your answer, what's above the division box, plus the remainder divided by the divisor. I know this sounds confusing, but this is just the long division algorithm. The tricky part is going to be here. What are you multiplying by to get that first term in each to be the same thing so that they cancel out when you subtract in the long division algorithm? All right, and so I think the best way to do this is just to show you the process. So here's our problem. X squared plus 4x plus 12 divided by x plus 3. So the first thing we're going to do is we're going to write this as a division problem the old-fashioned way, where the divisor's here, the dividend's inside. Okay, so first part here, second part here. All right, and now here's what I mean. You got to ask yourself, what do I have to multiply the first term here by to get the first term here? Okay, and what do I have to multiply x by to get x squared? And that is x. Okay, I'm lining up with like terms, so linear terms here. All right, and now, just like we did before when you were doing, 4/3 or 4 divided by 3 or 5 divided by 7, whatever, you're going to take this and multiply it by this, and this is a distribution problem. So x times x is x squared, and x times 3 is 3x, so we get that. And we are subtracting these, okay? So we get the line x squared minus x squared is 0x squared, so the x's are gone. 4x minus, so we are subtracting 4x minus 3x. Okay, probably should have had this fly in separately. This is a separate subtraction problem. Okay, so 4x minus 3x is x. Bring down your 12. Probably should have that fly in from up or fly down too, but that's okay. Now, we now have a remainder, but it's not a constant. So we have to ask ourselves, what do I have to multiply x by to get x? Not a trick question. We're going to multiply by 1, positive 1. So 1 times x is x, and 1 times 3 is 3. And again, it's a subtraction problem. This probably should be in parentheses. So it's going to be x minus x and 12 minus 3. Okay? X minus x is 0x, which is what we want, and 12 minus 3 is 9. Okay? So again, we did this when we solve systems of equations. We would subtract, same sign. These have the same sign. So we subtract them, and you're just kind of doing that triangle. X squared minus x squared. 4x minus 3x. X minus x. 12 minus 3 is 9. Now, we're down to a constant. Okay? So we're going to write our answer, our quotient, plus the remainder divided by the divisor. Okay, just like you did with back in the day in elementary school, 3 3/4, right? You would kind of go with your answer divided by your remainder over your divisor. So that looks like this. X plus 11 plus 9 over x plus 3. And then quickly, because I want you to try one, remember, when you're looking for your answer in a multiple choice test, you better make sure that your answer, if there's a remainder, has this divisor here, this x plus 3. If it doesn't, it's not your answer. All right? Now, let's give this one a shot. Write it down. See if you can write it down properly. Just try as best you can to work through this. Don't worry if you get it wrong. We're going to practice this again tomorrow, or I guess it would be today if you're watching it today. All right? So let's get started. Pause the video, give it a shot, and then I'll come in with the answer. All right, so we're setting it up, right? X squared plus 4x plus 12 divided by x plus 3. I'm going to ask myself, what do I have to multiply this first term by to get this first term type. What do I have to multiply? This just repeated. What the heck? There we go. This one. All right. So, I'm not sure what happened there, but here's the new problem. Okay. And we are essentially going to write it like this. Okay. Then you got to ask yourself, what do I have to multiply x by to get 3x squared? Okay. And what we're multiplying by is 3x, right? Because 3x times x is 3x squared. So I'm going to multiply by 3x. And then I have to distribute here. So 3x times x is 3x squared, and 3x times 5 is 15x. So that gives me that. And again, this is a multiplication problem. 3x squared minus 3x squared is gone. And then, a subtraction problem. 9x minus 15x is negative 6x. All right, bring down your negative 15, and then ask yourself, what do I have to multiply x by to get negative 6x? And hopefully you say that's negative 6. And then I'm going to use the distributive property here. So negative 6 times x is negative 6x, and negative 6 times 5 is negative 30. And again, here's where this triangle comes in handy. Negative 6 minus negative 6 is negative 6 plus 6x, sorry. And that's out. And then negative 15 minus negative 30 is negative 15 plus 30, which is positive 15. Okay, so again, work the triangle, and then write your quotient, 3x minus 6 plus 15 over x plus 5. I hope this video helped, and I will see you guys next time.